welcome to another video by SmartPath Tutoring, GCSE Biology. Today's video is about electromagnetic waves and refraction. There is a continuous spectrum of EM waves. All EM waves are transfer waves. They transfer energy from a source to an absorber. Example, a hot object transfers energy by emitting infrared radiation, which is absorbed by the surroundings. All EM waves travel at the same speed through air or a vacuum space. Note, electromagnetic waves are not vibrations of particles, they are vibrations of electric and magnetic fields, so they can travel through a vacuum. Electromagnetic waves form a continuous spectrum over a range of frequencies. They are grouped into 7 basic types based on their wavelength and frequency, from longest wavelength, lowest frequency, to shortest wavelength, highest frequency. Radio waves, microwaves, infrared, visible light, ultraviolet, UV, X-rays, gamma rays. As you move along the spectrum, frequency increases, wavelength decreases. There is such a large range of frequencies because EM waves are generated by a variety of changes in atoms and their nucleus. For example, changes in the nucleus can create gamma rays. This explains why atoms can absorb and emit a wide range of frequencies. Because each type of EM wave has different properties, they are used for different purposes. Refraction, waves changing direction at a boundary. When a wave crosses a boundary between two materials at an angle, it changes direction. This is called refraction. How much the wave bends depends on how much the wave speed changes. The wave speed depends on the density of the material. The higher the density, the slower the wave travels. If a wave enters a boundary and slows down, it bends towards the normal. If a wave enters a boundary and speeds up, it bends away from the normal. During refraction, wavelength changes. Frequency stays the same. If the wave travels along the normal straight into the boundary, its speed changes, but it is not refracted. The optical density of a material measures how quickly light travels through it. Higher optical density, light travels more slowly. Lower optical density, light travels more quickly. Drawing refraction rays. Step 1. Draw the boundary between the two materials. Draw the normal align at 90 degrees to the boundary. Step 2. Draw the incident ray meeting the boundary. The angle between the ray and the normal is called the angle of incidence. If you are given the angle, use a ruler and a protractor. Step 3. Draw the refracted ray on the other side of the boundary. If the second material is optically denser, the ray bends towards the normal. Angle of refraction is smaller than the angle of incidence. If the second material is less optically dense, the ray bends away from the normal. Angle of refraction is larger than the angle of incidence. Key facts to remember. EM waves are transfer waves. EM waves all travel at the same speed in a vacuum about 3 times 10 to the power of 8 meter per second. Frequency increases and wavelength decreases across EM spectrum. The EM spectrum order is radio, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Key facts to remember. Refraction happens when a wave changes speed as it crosses a boundary at an angle. If a wave slows down, it bends towards the normal. If a wave speeds up, it bends away from the normal. During refraction, frequency stays the same. Wavelength changes. A wave traveling along the normal does not change direction. Thank you for listening.